A not uncommon thing you might have to do is provide some sort of web interface, be it an API or an actual HTML interface, to a database. And I'm going to go through a simple example here where I provide access to a SQLite database using the database SQL functionality to provide a web interface, and then I'll change it from just producing text to producing JSON to make something that looks a bit like an API, and then I'll actually add methods to it so we can update the database and see how it operates. So first of all, I've prepared a fairly simple program which allows us to access a database of scientist names, and let me just bring up that database so we see what it looks like. So there's a number of scientist names in here with different field values, and within the program I have defined an API, a web-based API, which I'm going to use to access it. So let's first of all start with main. I just connect to the database in a very familiar way, which is to use SQL.open from the database package and that particular database file. And then I'm actually storing the database handle, if you like, in this database server struct, which is defined here. And for the moment, that's all it has, but it could be many other things in it. And I'm going to use the net HTTP package to start serving HTTP on port 8080 on my local machine. And there's one route here, which is /API, and it's going to call a method value. If you remember earlier in this, I talked about method values. Well, DS, which is a database server, has a method, which is here, API, which has the right signature to be handled by a handle func in net HTTP. So I can just call it in there. This is the method value here. And so when anyone makes an HTTP request to /API on here, we'll end up being sent into this function here, and this function has a couple of parameters. One is this response writer, which is where you send your response back to the user, and there's a pointer to the request itself, which came in, which has already been passed. And the API I'm going to define is pretty simple. It allows you to look up somebody by last name and get their first name. So first thing I do is I parse any form values so that I can parse the last name. And I'm going to expect there to be a last name, so last equals something. And if there isn't, I'm going to throw a bad request error back saying it's missing. And if there is, I'm going to get the last name, and then I'm going to go to the database and pull out the corresponding record. So let's go into here, and I'm going to say, I'm going to use the database handle, which is in this database server, and to do this query, get the first name, where the last name equals that, and I'm using here a placeholder and passing in last as a parameter to query. And if that goes wrong, then I'll say there's a problem. And if not, I will get the first row. I'm assuming there'll only be one row. Of course, there might be more than one, but in this case, it's unique. Scan out just the first name. That's all I've asked for here. So I can just do a scan like this. And I'm just going to print it out. I'm just going to say, this person has this name, or if it's not found, this is what happens. So this will end up returning a 200 because there's no error. And this whole thing right now is a working server which can talk to this database. So let's just make sure it builds. So that looks pretty good, and run it. So if you look at this last thing here, listen and serve, it's now sitting waiting for any requests on port 8080. And what I can do is just go over here and just do a curl against it. So 404 not found because there's nothing on /. If I go to the API, I'm going to get an error, missing last. Let's just get the headers out of that. You're going to see there it says 400 bad requests, because that was the thing I told it to do up here, which is if there was no last, then give me a 400 bad request. All right, let's see what happens if we ask if somebody who is in the database. Let's ask for Ada Lovelace. So we're going to go last equals Lovelace. And there you see, Lovelace first name is Ada. So it's gone through, it's found the thing, it's done this database query, it's got the rows, parsed it, and returned it to the user. And it's really a very small amount of code to be able to do that. Let's just do one more. Let's try one where the person is missing. So I don't see John Logie Baird in here, and Baird not found. So that was the other branch of this here. So that's a basic hookup of a web-based interface to a database. Now I'm going to go ahead now and change this. Obviously textual responses aren't that great. Let's actually return a JSON response instead. So it'd be much nicer if this API returned JSON rather than returning a bit of text, so we want something a bit more structured. And that's actually pretty easy to do. Go has an encoding/JSON package, which will do most of the work for you. So what I've done is I've modified the program here so that it now reads all the fields from the database to make it a bit more interesting, stores them in a structure. I'm going to use an anonymous structure since I don't need to name it, and then marshals that into JSON and writes it out. So we'll just take a look at how that's done. You just import encoding JSON here, and this is all the same. I've modified this query so that rather than just getting the first name, I get all the fields. And I've now, when I actually find the result, I've made this result variable here. You'll notice I'm using an anonymous structure because I don't need a type for it, and it just contains all the fields that I'm retrieving, the ID, first name, last name, and whether they're alive, which I then scan in. Unfortunately, I have to scan them all in like this. The scan interface won't let me easily scan it into the structure, but it still works. And then I'm going to use JSON marshal, which is going to take that, create it into JSON, into this thing J. Obviously, if something goes wrong with that, that's an internal server error. We should talk about that. And then I'm just going to write the JSON out to W, which remember is the response writer, and that's it. So that's the change to make it work with JSON. So let's just build that guy and run it. Okay, so that's running, and we'll ask it to look up somebody called Lovelace using their last name, and I'm piping it through JSON PP just to get some nice structured output. And there you go. So that's now queried the database, created JSON, and output it in a much more structured format. So we're getting close to now to something which is an API. The big thing we haven't got right now is any distinction between getting and putting. So what I'm going to do is I'm going to modify this so that I can actually update the database by adding new people to it using a post. So having turned it into something that provides JSON, the last step is to make it update the database, to make it into an API that actually does something useful. So what I've gone ahead and done is modified the code so it looks at the HTTP request method to see whether it's a GET or a POST. If it's a GET, then it's going to do what it did before and look up someone in the database and return their details. If it's a POST, then it is going to go ahead and add that person to the database. And for a POST, we're going to have a first name and a last name to be inserted into the database. So I did a little bit of refactoring. Let's just take a look. I took out everything that was doing the GET from the database, the query here, and made it into a function called GET. And I created a new function called marshal. And what marshal does is it writes some arbitrary piece of JSON to the response writer. So we're going to use that a few different places to write different bits of JSON. I also added a Boolean called success to the result, so I could say whether something was successful or not. So all of my JSON responses will have a Boolean success or not. And so the simple GET API now is handled by the API function. So everything has a last name, so I check the last name first. And then I go in and look at the request method, and if it's a GET, I do this GET thing, and if it's a POST, I do the new POST item. And the POST function, it has to get the first name, because we need the first name, so make sure that's there. And then it's simply doing an insert into with these placeholder elements for the first name and the last name. Let's tidy that up. Error, obviously, if something goes wrong, and then just return a success. So it'll return a very small piece of JSON that just says success. That's what this anonymous struct here will do. So let's make sure that builds. Looks good. Okay. Now let's go ahead and look someone up in here. So let's look up Ada Lovelace again. Let's look her up. Okay, there she is. That gets her details. Let's look up someone who's not there. I'm going to look up Mary Somerville. So that's not successful. She doesn't exist. And obviously you could have a different message in here. So let's add Mary Somerville. So what I'm going to do is I'm going to turn this into a post. And I am going to say first name, Mary, and success. That's been added to the database. And let's just check that she's there. And there she is. She's been added, Mary Somerville, and that's her particular ID. And obviously we could go into the database and we can have a look at the record as being created within there. So as you can see, it's not a lot of code to start building up an API like this. And obviously there are many other things you could do around templating, because Go has a nice templating library. So you might want to have templated responses in some cases when it's HTML. But basically between encoding JSON, database SQL, and net HTTP, those three packages, you can build a fully featured API server that talks to a database with really no problem at all.